Let's solve this given differential equation. We know that this equation is homogeneous because the right-hand side is equal to 0. And we can see that the variables are the coefficients of this equation. More importantly, you can also note that the degree of the variable is equal to the order of the derivatives. So this is a Cauchy-Euler equation. Hence, we know that the solution of the Cauchy-Euler equation is y is equal to x power m. To find the values of y prime and y double prime, we'll be taking its first and second derivatives and substitute them here. Now let's substitute these values here and here. Now we can notice that x power m is common in all three terms. So we're going to factor it out. And you can see that x squared is going to be cancelled out with the x power negative 2. Similarly, x is going to be cancelled out by x power negative 1. Hence, all the variables in this equation are going to be cancelled out, giving us our auxiliary equation. But let's write that directly. We already know that the x power m cannot be equal to 0 because it is a solution of this differential equation. Hence, you're going to be left with this term. We've got the values of m as negative 1 and 4, which are real and distinct. So according to the case first, we are going to be writing its general solution, y is equal to c1 x power negative 1 plus c2 x power 4. Let's solve this ordinary differential equation. You can see that this is homogeneous equation because the right-hand side of the equation is equal to 0. And you can also notice that it is having variable coefficients where the coefficients degrees are matching the order of the derivatives. So this is a Cauchy-Euler equation. And we know that the solution of the Cauchy-Euler equation is equal to x power m. To find the solutions for the y prime, y double prime, and y triple prime, we'll be taking its first, second, and third derivatives. Before we go along, we know that x power m is common in all four of these terms, and it will be factored out. Eventually, we'll be left with x power m with the auxiliary equation here equal to 0. And we already know that x power m cannot be equal to 0 because it is a solution of this equation. So skipping those steps, along with that, I will also not be writing any variables, x cubed, x squared, x, as those are going to be cancelled out by x power negative 3, x power negative 2, and x power negative 1 respectively. So I'll be writing this Cauchy-Euler equation directly. Now we are going to be solving this equation by factorizing this cubic expression. For that, I'll be using synthetic division And by using trial and error method, I'll try to find its first root. Let's assume that maybe the first roots are at 1 and -1. So when substituting 1 here, we get 1. So m minus 1 is not the factor of this equation. Let's try m plus 1. This is also not equal to 0, and it is not satisfying. So let's try another values of m. Let's try 2 and minus 2. So m minus 2 is not a factor. Let's try m plus 2. So m plus 2 is indeed factor of this equation. Let's apply synthetic division. We're going to be writing the coefficients of this cubic expression here, and then apply the synthetic division like this. We're going to be writing the first root here, which was found out to be m is equal to -2. Writing -2 here, 1 as it is. 1 times -2 is going to be -2. Adding these. Now repeating the same process. This is the remainder, which is equal to 0. And these are the coefficients of the quadratic equation we are going to be left with. So let's rewrite it. Now, we are going to solve this and find the roots of this equation. We know that it is going to be -2 from m plus 2. And for m squared plus 4 equated to 0, we get we know that the under root of -1 is equal to iota, which is imaginary. So instead of writing this, I'll be taking the under root of 4 and writing plus minus 2 iota. Now you can see that we are having 3 solutions of this differential equation. M is equal to 2, which is real part, and M is equal to conjugate complex pairs. So we're going to be writing our general equation in a way that fulfills both of these conditions. Now, substituting 2 here, and we can see that the real part here, alpha, is equal to 0. So x power 0 is equal to 1. This is going to become 1. While for this, beta, we are going to be substituting 2 here and here. This will be giving us our general solution.